Another property of logs is when I have two things being multiplied together that I'm taking the log of. An equivalent statement is log with the same base, a, m, plus log base a, n. Notice when it's in its multiplication form, it only has the word log once, the function log. When it's in its addition form, log, you're taking the log of both separately. So here we have a question, and the directions might read, expand the logarithm. This is in its multiplication form, so we can expand it to be an addition form of two separate logs. So we would write log. We keep the same base. Let's take the first thing, 3, add to it the log, same base of the other factor, x squared. There's one more step we can do here. If you remember, another log rule says an exponent can come out to the front. So we're going to write our exponent as our coefficient. This would be a fully expanded logarithmic function. On this one, let's go the other way. This is an expanded form for addition, so I can go backwards and put it in its multiplication form. Before I can do this, I cannot have any coefficients. So this coefficient is going to have to go back up and be an exponent. Let's work on this part. 3 to the 4th is 81. So log base A 7 plus log base A 81. Now that I have two separate logs by addition, I can use our rule and multiply the 7 times the 81. 7 times 81 is 576. So the final answer here would be log base A of 567. This property of logs, we're taking the logarithm of a quotient or a fraction. In this case, if you need to, you can have an equivalent statement of the log of the numerator minus the log of the denominator, keeping the same base. On this question, the directions would state, expand the following log. We have a fraction or a division problem. We're going to take the log base 2 of this quotient. So we'll expand it to be the log base 2 of 8, which is the numerator, minus the log base 2 of the denominator. Now we have a couple other things we can do. 8, we can change 8 to be a base 2 with an exponent. 8 is equivalent to 2 cubed. On this one, as we go, the exponent comes out front to be the coefficient. Now, if we look at this and apply some of the log rules we already know, since the base matches the number, we know the answer to this term is 3. Now we've simplified our log. This question is in its subtraction form, and the directions might tell you write as a single log, which means I want to go backwards to the quotient. Since the bases match, we're allowed to do this. Notice the coefficient here. Before we can start, we've got to take it back up to be an exponent. are two separate logs, so we're going to write as a single log. The first will be the numerator, and this will be our denominator. Now, at this point, I hope you notice that this is the difference of two squares, so we can factor the numerator. Now, since we're in factored form, we're allowed to reduce. Notice we have a x plus 1 in the numerator, x plus 1 in the denominator. Actually, we have 2, but we're going to cancel this one with one of these, which will just leave us 1 factor of x plus 1. So our final answer will be log base 4 of x minus 1 over x plus 1.